this class. In this video, we are going to discuss the difference between this three-membered saturated heterocyclic compound, right? So we have studied both. So we have studied three-membered also heterocyclic compound, and this is four-membered heterocyclic compound also, right? So let us see one by one. So before going further, these things I have explained you, right? So let me take the example of this. First, I will start with this aziridine. Aziridine. So it is three-membered heterocyclic compound containing nitrogen, whereas four-membered it is called azitidine. Azitidine, right? So difference is here. It has three-membered and containing nitrogen, and here four-membered containing nitrogen, right? So I have told because of this angle strain, what are the things here? Angle strain will be more. Angle strain will be more because it is three-membered. Here less angle strain. Less angle strain. Why this three-membered is having more angle strain? The reason is 60 degree, right? So it is very deviated from 109 degree, right? 60 degree. So it is very deviated from 109.5 degree, I can finally call. Here it will be around 90 degree. So it will be compared to that 60 degree, it is nearer to this 109.5 degree, right? That is the second point, right? This thing you need to remember. So because of this angle strain, what happens? This nucleophile ring opening reaction will be very faster, right? So here they will give fast nucleophilic ring opening reactions, right? This thing is common for everywhere, right? So further here, so it will be slow nucleophilic ring opening reactions, right? So what I am telling, just you write. I am writing shortcutly here, ring opening, right? So you have to write. So next thing, so these are the few difference. So here we saw that these nitrogen having lone pairs, these are less basic. Why these are less basic? The reason is it has got more s character. More s character means less basic, right? Whereas here these nitrogens are having lone pair, it can give easily because s character will be less compared to these three membered. So these are more basic. So what happens, since these are less basic, so electrophilic ring opening reaction will be slow here in three membered case, right? Whereas in four membered, electrophilic ring opening reaction will be faster because it can easily donate the lone pair, right? So these are the common difference everywhere. If you not only this aziridine and azitidine, but if you compare these oxygen and oxytanes, they are also same thing, same rules will satisfy, right? And also for thyrenes and thietanes, right? So this is common. So what are the extra things what we discussed? That thing we shall study now, right? So that is nothing but, see, first let us see this azitidine, right? So structure is like this. So this is azitidine, right? So if you see the other things is pK, if you see this pK, it is around 7.98, whereas for this four member nitrogen containing group, its pK is around 11.29. I have told greater the Ka, smaller will be the pK. Here you can see that if you compare these two, its pK is small, whereas its pK is big. So it means if its pK is small, its K will be big. If its K is big, it means it is more acidic compared to this one. It means it is less acidic, right? So reason I have told, here S character will be more. So more S character, it can easily hold the electron density with it, right? So many times I have told, so I am not explaining those things in detail here, right? So greater the S character, greater it can hold the electron density, right? So H plus if removes, the negative charge will be easily taken by this compound, right? So they will be having greater Ka value, right? So this is the difference. So other things, if I want to tell one more thing, that is if you compare this four membered ring and three membered ring like this, right? Let me continue this, right? So what are the difference? So one more is, here I have told energy barrier for pyramidal inversion will be more. in three membered, whereas here the energy barrier, same thing, for pyramidal inversion is less here, right? So greater the angle strength, greater will be the energy required for pyramidal inversion. So we can isolate optically active compounds, right? Three membered this aziridines, sorry, aziridines we can easily isolate, right? This is one more point. Other point is nothing, basicity, everything I have explained, right? Those things I have explained. This will be having less basic and this one will be having more basic, those things. So it is less basic, it is more basic. Just you write basic here also, right? So this is one thing. And the last one is dipole moment. So it will be like this dipole moment. If you see the dipole moment, it will be around 2.1 to 2.4, whereas for this dipole moment will be around, no, they haven't given dipole moment here, right? So they haven't given dipole moment, only these were the difference thing, right? So it will be less basic, whereas this will be more basic, and they have compared this basicity to secondary or tertiary amine, so it behaves like secondary or tertiary amine. These things also I have explained during reactions, right? So no problem. So next compound, let us discuss about this one. That is oxyrane, right? And one more is oxytane. Oxyranes and oxytanes. Let us discuss about them, right? So structure, if you want to draw the structure, so oxyrane means three membered oxygen containing group, right? Other things same, basicity, everything is same as that of aziridines and azitidines. Here also more strain, more angle strain, and less basic, fast nucleophilic ring opening reaction, slow electrophilic ring opening reaction. And here all things are opposite. Here it is uh, less angle strain, more basic, slow nucleophilic ring opening reaction, fast electrophilic ring opening reaction. That you all, that is same with respect to all. Only difference is, see here, if I see dipole moment of this, it is observed to be 1.88 d, whereas dipole moment if you see here, it is around 2.01 d. That's the difference, right? No much, right? So that is the different thing. So last one that is nothing but thyrane, this thyrane, and this thytanes. So what are the thing? So difference is, just first one is the structure. So it is three membered heterocyclic compound which contains sulfur as a heteroatom, right? Other things remains as it is, right? So here also no much difference, everything will be same. Only just if you see dipole moment, whether, let me check whether they have given dipole moment of that or not. So they haven't given for 4 membered ring, but for 3 membered ring it is 1.66 d. So this is the dipole moment, nothing much. And one more thing which I have explained is electron density. Electron density on sulfur is more in 4 membered ring, then comes this 5 membered ring. This thing I have explained during reaction. Then comes this 7 membered ring, right? So I have told how to draw this 7 membered ring like this. Lastly the 3 membered ring, because S character will be more, so the electron density will hold it, it never gives, right? So this is the order of electron density. I have told this order of electron density. So nothing much difference. But sometimes in the reactions I have compared these things. For example, I have compared this oxyrane and this thyrane. Here what I have, different things I have told. Both oxygen and sulfur belongs to same period, right? Sorry, same group, not period, same group. What kind of group? It is oxygen family, all belong to oxygen family. So what are the difference? Its electronegativity is around 3.5, whereas it's around 2.5. So as we go down the group, size increases. So what are the difference? So oxygen is having more electronegative, and size of sulfur will be more, big size it is. So because of which some difference comes. So what is, one is, see, this will be less basic. If I compare only these two, I am not comparing 3 membered and 4 membered, I am comparing only these two, right? So this will be less basic, whereas this is more basic, we can call. No, I told it wrongly. Sorry, it's wrong. So it should be ulta, means a reason also I have told these things, right? So the reason is this one. See, this will be more basic and this will be less basic, right? The reason is I have told, I have compared this with ammonia. NH3 I have taken and I have taken this pH3. I have told this is more basic than this, so basic order. The reason is nitrogen will be having small size, so electron density will be more on nitrogen. So phosphor will be having bigger size, so electron density will be like this, right? So size, if I see electron density means electron to size ratio, it will be less, whereas here it is more. So it can easily donate the electron density to this electrophile compared to this one. So same thing holds here also. So if I tell the basic character, this will be more basic, three membered. Oxygen will be more basic than sulfur. So that's the one thing. And one more difference if I want to tell, see, I have told this will follow octet rule. So if I count 2 here, 2, 2, 2, total 2, 4, 6, 8. Total I will get 8 electrons, right? But here also see, 2 here, lone pairs will be there, 2 2 2, it is also 8 electron. So both will follow 8 electron. But if I add some oxidizing agent like H2O2, it will convert to oxides like this. So here if you count, it will be around 10 electron and it is 12 electron, right? So this sulfur family will expand its octet, right? So it can expand its octet. So those were the different things which we have studied. No, and other things are as it is, nothing much change, right? I hope you have understood this three membered and four membered saturated heterocyclic compound. In next class, let us discuss this seven membered heterocyclic compound. Till then, take care and have a great day.